Alright, so we have seen in previous videos about the break continuum, and the last one we're going to see is a yield statement. So what is a yield statement? Just like we have seen other jump statements, yield statements a little bit more complicated and a little bit more scary, but don't worry, we're going to explain to you guys, and at the end of this video you guys going to have a very good understanding of the yield statements. If you guys know here, you guys need to put inside your system instead of you say we're putting using system, because we are using the system, and this guy here using system.collections.generic, you guys need to put a generic. So now you guys have a little bit of idea what I'm talking about the yield, because yield we have we're going to use the system C# system and then collections and generic, because we're going to use generic programming. What is the generic programming? Generic programming is code reusability. So if you guys want to use code again and again and again, that's called generic, and that comes into C++ as a template. So if you guys don't know anything about template is inside the C++, because C# is written inside the C++, so it has all the functionalities of the C++. So the yield statement is a contextual keyword. If you guys remember earlier, the beginning of this course, we have mentioned that the word contextual is a word that provides a specific meaning in code without being reserved words. So the yield keyword performs a custom iteration over a collection like a list and array. So as I said before about the collections, this collection refers to the list and arrays. The yield keyword is used to do custom stateful iteration over a collection. The yield keyword tells the compiler that the method in which it appears is an iteration block. So now you guys know we have mentioned about the method, and we are slowly getting there. So we have put it there, method. So one thing you guys remember, so simply put, we say to use yield statements in an iterator provides the next value or signal at the end of the iteration, just like say break, or just like a go to, because as I said before, that use yield statement in an iterator provides the next value or a signal at the end of the iterator. So it indicates that the method operator or get accessor, which we're going to discuss in the future videos, where it appears preceding a return or break statements, is an iterator. The sequence returned from an iterator method can be consumed using a for each statement. The yield statement makes it possible to return values as they are produced and consume them as they are available, which is especially useful in an asynchronous context. So we have used this yield statement in PHP. So in PHP, yield statement causes the function to return each value. Say for example, we have a document as soon as it becomes available. So yield statements causes something to become available as soon as it becomes available. This means it is efficient with memory. It does not keep the objects in memory in an array to return them all at once, but instead return them one by one immediately after creation. So yield, just like drops of water, for example, keep it this way. So instead of the floods coming, which gonna overwhelm our a lot of water is gonna come in and blocks the drainage, yield makes it say drop by drop. Say brings it drop by drop. So it don't want to overwhelm the memory. That's a definition inside say if you guys know the PHP, but we are not learning PHP, because yield is also in PHP and yield is also in say C++. Put simply, the yield just makes it very simple to implement an enumerator. So if you wanted to write a method that returns an I enumerator, and we're gonna put it like that, I enumerator, and we're gonna put this one is less than greater than, we put a T, and this is called template. This is generic programming. It saves you having to create the enumerated class. You just yield one result at a time, and that the compiler takes care of the details under the cover. So for example, the C# compiler automatically pauses the execution of your enumerator loop and returns the current value to the caller. There are two forms of the yield keyword. The first one is the yield return. So we have a yield return. So this guy here, yield return, returns one element at a time. The return type of yield keyword is either I enumerable or I enumerator. The yield break statement is used to end this iteration. So now we're going to have another one. We have yield break. We have two kind of yield. So we have a yield return, which returns, and the yield break, which going to break this iteration. So yield break is just terminates the iteration, and put simply, yield return returns an expression at each iteration. So at each iteration it returns one statement. Instead of flooding the memory, it returns as soon as it's available. In this video we're going to see yield return, and the next video we're going to talk about yield break, because you guys need to understand the yield return before we jump to the yield break to break the iteration. Alright, so now for example we have as I said before, we have I enumerable. So we put I, we put an enumerable here, and you guys looking here, that's C# is completing this I enumerable here. So we have instead of a string, we have the data type of int. We're gonna put it int here, and then if you guys, for example, as we have seen, we want to say even numbers. We want even numbers in our for example, for each loop. For example, we just want even numbers. So now here we put an int and say for example number, for example up to the number. We put up to our you guys can say up to the number. So now we have I enumerable. If you guys put I enumerable and if it's not working, make sure you guys going to put this one using system.collections.generic, because we are using the generic programming. If you guys don't understand the generic programming, don't worry, and we're going to explain to you guys about the generic programming in the future videos. Now we're going to run a for loop. So we want to put a for. This is slightly different. We put a int I equal to 0. We're going to start from 0, and we put a I is less than, and we're going to use this up to. This guy here inside this is called parameter. So you can use your parameter here, because when you guys put this parameter, it means you guys need to put arguments, and I'm going to show you guys how to put arguments. If you don't put anything here, say if you put int here as a parameter, then if you guys don't put your argument, then C# is going to be extremely angry. So whatever numbers we're going to put, say for example we put up to, so we put up to here, then the C# is going to take that one, and it's gonna, we're gonna put a I plus equal to 2. Then we're gonna put a, say for example we incremented that one by 2. So we put a yield return I. As you guys gonna see here, the C# has completed this one. So this is a return type, yield return. And how we gonna say use say for example this guy here, enumerable even numbers, how we gonna use this one inside our loop, for example. Yeah, we're gonna use it. Say for example we're gonna come here and we put a for each. Now here underneath here for each we put a int I. What we have here, even numbers. So we put a even numbers here, and as I said before, you guys need to put your arguments here. And what is your argument? Say for example you guys can put any arguments here. Say for example we put a 20. Now this is our arguments. As I said here in your parameter, if you guys gonna put an int, say any number, or you guys can just put a number. If you put a number, you just put a number up to, say for example this 20, and then you're gonna put a yield return I. So you guys need to put this one as an argument here. So now we're going to come here and going to put a console.writeLine. As you guys going to see here, C# knows already here, and underneath here you guys need to put a console.writeLine. So we're going to put a console.writeLine here, just like the C# putting here, just so we can put a space here. So we are putting a space in between here. Now we're going to run this for each iterator. So we put a int I in even numbers. Where is this even numbers here? Int up to, we provided number here as an argument. So we're going to print one by one all of these numbers provided by we have say even numbers, because we want only even numbers, just like in the previous videos we have seen even numbers. So that's exactly, we want from say from 0 all the way to 20, we just want to see even numbers. So we're going to run our program. Alright, so our program has executed. If you guys look in here, we have all the even numbers. We have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. So how this one was possible? Because as we said before, that the yield statement causes the function to return each value as soon as it becomes available. So it's efficient with the memory, and it returns this one as soon as it's available instead of flooding your program. So that's what the yield works here. And keep in mind, this one we are using with the enumerator, our enumerable here. We can use enumerable. So you guys look in here, how cool is this program? We just putting some sort of enumerable which belongs to the collection dot generic here. Generic programming is like templating in C++, which is generic code reusability. Generic means we can use this code again and again and again and again. This is yield return, and the next video we're going to see what is yield break. Yield break, as I said before, it terminates the iteration. Alright guys, that's it for this video. Thanks for watching, and don't forget to subscribe. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.